let's go ahead and get started. The QR code to download the slides is also on the last one as well. If you want to follow along, you can download them now, or you can pick them up later. That's fine as well. Please turn off your cell phones. That's as a courtesy to the people who are here, and also as a courtesy to those who are listening to the recordings later. So please take care of that. If I've counted correctly, this is the 12th time you've seen this slide. So I'll just add one thing. I'm a local group leader, and I'll tell you what, go find your local group, support your group, become a speaker, and network. You'll never know when you need your networking to help you find something or get an answer to a question. And usually when you decide that you need it, it's too late to develop it. So develop it now. Help some other people, and find some help for yourself as well. All right. I think that you've probably read a little bit about me already. I'm going to come down off the stage if that's all right. You've probably already read a little bit about me, so I won't go into a lot of my technical details, but let me give you some fun stuff about me. I actually really enjoy strategy board games. I love a good, complex board game. I also enjoy running. I've got this really weird thing where I actually feel better after a run than I do before a run. I don't know how that works either. It's really weird, so I just have to live with it. But I enjoy running. And lately I've been dealing a little bit more with ham radio. I think my furthest contact to date was in Argentina, about 6,000 miles. And so I'm pretty proud of that. I actually heard a station in Antarctica one day, but there were so many other people that were trying to talk to that station that I couldn't get through, so it didn't count because it was only one direction. But ham radio is quite a bit of fun. All right, we're here today because we are concerned about disruptive change. Now, disruptive change is something that completely changes or severely impacts the way that you do things, a dramatic change or a dramatic shift. Now, we've picked an industry to work in where this happens frequently. All right, about every 2 years or even in a shorter time frame, there's something new that we're working on, that we're trying to implement. So we are in an industry that's filled with disruptive change. Now, some of them I have up here on the board. There's the move to the cloud. There's containerization. There's the rise of NoSQL databases. There's all kinds of technological change that happen all the time in our industry. But there's more than that. There's also business process changes, right? Changes to the development life cycle. There's the move to agile, adding code reviews into your development process, or adding or changing your source control software, right? Those are processes and business processes that work around it. There's also business changes, organizational structure changes. All of these things can be disruptive. Now, oftentimes these things are kind of scary because we're used to something that's the status quo, and it's hard to look at something new, and it's hard to adopt new things. We want things to stay the same because that's where we're comfortable. But companies that stay comfortable, that stay the way they are, generally don't perform very well in the market. Markets change, technology changes, outlook changes, and unless you are staying on the front and implementing the correct things, the correct technology, the correct process changes, you eventually find that you fall behind your competitors and you become somewhat irrelevant. And there's examples of companies that have done that over time and have really dropped off the marketplace. So what we're going to talk about today is how to handle disruptive change. And we're really going to focus on helping 3 specific types of people today. The first type of person we're going to help is the person who's in charge of making that decision. You know, you are tasked with determining which disruptive changes are going to benefit your company and which ones you should pass on and let them slide by. We're going to help that person understand how to make a good decision and make it data-driven so that it's objective and not subjective. The second type of person that we're going to help is not the one that's making the decision, but someone who's influential in that decision, right? They're going to come to you and say, hey, help me make a determination here. What are the factors that we need to consider? And how will we know if this is really going to benefit us or if it's something that we should pass on and wait for the next thing to come around? So we're going to help that person with the skills that they need. The third person that we're going to help is someone that doesn't fit into either of those 2 categories, but that's the direction they want to go. They want to be influential. They want to be the decision maker because you need those skills now so that you can work your way into that position, so that you can be successful in directing your company, your group, your department in the way that it needs to go. So how are we going to do that? Here's the 4 things we're going to cover today. These first 2 bullets are soft skills. How to handle that initial encounter where someone has presented or you're being confronted with a disruptive change. How do you handle that first encounter and what do you do? Because that first encounter, how you react that first day is key, not only to making the right decision, but encouraging innovation. Second, we're going to talk about a perspective that you need to have and how you can develop a perspective that is appropriate for handling disruptive change. Then we'll move into some more hard skills, some more technical skills. How do you do a data-driven evaluation of a disruptive change? How do you make it objective rather than subjective? How do you determine whether or not it's going to work for you? Not how it worked for someone else, but how it'll work for you. And then at the end, we're going to spend just a couple minutes talking about how to give a hardened presentation. By hardened, I mean a presentation that can stand up to scrutiny and that can stand up to, I just lost the word, examination. It starts with an E. Examination. Evaluation. One that can stand up to being subjected to scrutiny. One that can stand up to scrutiny. That's a good word. It doesn't start with an E, but I'll use it anyway. It works. Okay, so this is the path that we're going to go through today. All right, let's start. New things are always good, right? You've been here at the summit. How many new things have you learned while you've been here? A ton, right? This is the 12th session, so there's at least 11 new things that you've learned while you've been here at past summit. These disruptive changes come from a variety of places. It might be from a users group meeting, from a friend, from a former job. These are all ideas. They come from a variety of different places. What they all have in common is a sense of excitement, right? Hey, here is something that I think we should do. I think it'll make a big difference. And that excitement is what helps your company to progress to the next level, to become a market leader, and to improve itself beyond where it is today. Now, this excitement for things that are new, there's actually a name for it, philonism, a love for novelty or things that are new, is a good thing for your company. And you want to make sure that the people who are bringing new or novel ideas to you are recognized for that and that you direct their excitement, not squash it. If you end up squashing all the excitement for things that are new, you'll have a really hard time innovating and making progress for the next 5 to 10 years. You need to channel it so that the directions that you go, the disruptive changes that you implement are good, but you want to make sure at the same time while you're picking the ones that you want to implement and not the ones that you don't think will work out well, that you don't squash that excitement. Now, people have many different reasons why they bring new ideas to you. Underneath that excitement, it's generally something like this. They're just inquisitive or they're looking to advance. Maybe they've found something that will make their job easier. Whatever their own personal motivation is, the outcome of that is, let's improve the company. Let's do something that will make things better. And that's a good thing. This excitement, this idea of let's do something new, let's make change, is good. What you have to do is direct it to make sure you're doing the right things. Take a moment to consider where your company might be 5 years from now or 10 years from now. And if you want to do a really fun thought process, think about where you were 5 years ago or 10 years ago. What kind of things were you using technologically? What were the servers that you were using? What were the processes that you were using? What was the organizational structure like? Is it the same today? It's probably not. My company's not even in the same building. A lot of change happens 5 and 10 years down the road, so it can be difficult to see down the road, but it's very important to plan and say, all right, here's a disruptive change that's going to make things very different. Is it going to make things better 5 years down the road or 10 years down the road? You also need to do the same thing for your career. Where do you want to be 5 years down the road or 10 years down the road? Let me share a personal example with you. This happened about 5 years ago to me. We had a third-party company that came in and looked at our organization, our structure, and how we did our work. And they made a suggestion. They said, you know what? We noticed that you're using Microsoft products, specifically SQL Server, quite a bit. And we were. They said, you know what? We changed from using Microsoft SQL Server to using Postgres. And we found that it was cheaper, faster, and better. We think that you guys would have some similar benefits if you switched from using SQL Server to using Postgres. Now, I'll be honest, I was a little bit defensive. right? I had 15 years experience using SQL Server, and it was working great for us. We didn't have any problems. Why in the world would we switch when everything was working so well? I didn't want to give up my 15 years experience. I was in a really sweet spot in my company. I was the go-to guy for everything database related. So if somebody had a problem with performance, they couldn't get something to work, they came to me, we worked on it together, they went back happy, it was awesome. And I didn't want to give any of that up. But I did one thing right, and that was I created a space between when the suggestion was made and when the decision was made. And in that space, I had a chance to think. And I realized, you know what? If Postgres really is faster, cheaper, and better than SQL Server, the best thing for my company long term is to switch and to do it as soon as they can. And even though I have 15 years experience with SQL Server, the best thing for my career is to switch and to become the Postgres expert inside my company. So we started an evaluation to see whether or not Postgres would actually be better for us than SQL Server. Now, I'm not going to conclude the story now. This one actually comes up at several different points during a presentation, so I'll come back to it. But there's actually an accounting term that describes this phenomenon. It's called sunk costs. In accounting, when you talk about sunk costs, you're talking about something that you have spent, money you've spent for something in the past. Let's take, for example, you've determined that you need a new building. And if you build a new building, you're going to reap $10 million in benefits. The new building is going to cost $5 million. So it's great, a wonderful investment. Let's spend $5 million to earn $10 million. Let's go ahead and do it. As you get into the process, you get halfway down the road and you realize at some point that you've actually spent $8 million and you still have $5 million more to go before you're finished. Well, what do? That's $13 million. Ideally, you'd have never started the project, right? Nobody's going to spend $13 million to save 10. It just doesn't work. But at the point where you've already spent 8, the 8 that you've spent is water under the bridge. It's done. It's a sunk cost. It's already spent. The only information that is material or important to your decision is that you have $5 million to spend to make a $10 million benefit. Right? If you stop at 8 and say, okay, we're done, we're finished, then you spent $8 million and you have 0 benefit. If you continue on, you spend 13, but you have a $10 million benefit. At any point in your career, your previous experience is a sunk cost. You have to evaluate, where do I want to go from here? What is the next best step for me to take? Okay, now, in that first encounter, when someone brings an opportunity to you, a disruptive change, whether it's technological, business process, or business organization, you have an opportunity here to build a bridge or to build a chasm, to build a wall. And it's very important to build a bridge. The very first step towards building a bridge is to validate. And what I mean by validate is, first, don't panic. Stop. Resist your first impression. With disruptive change, your first impression is always going to be no. Status quo is good. There's not been any problems. Let's keep things the same. Resist that, just for a little bit, but resist it. Ask questions and listen to what they have. Take what research they've done, what experimentation they've done, the ideas that they have. Where is it going to make sense? Where is it they want to apply it? And why do they think it'll be beneficial? There's a really neat opportunity at this point to also magnify or expand on what they're suggesting. Now, what that might look like, here's an example. Let's say Barbara comes to you and she's got an idea that she thinks Docker is going to help you in your QA environment. And she says, you know what, if we apply Docker into our QA environment, I think we'll save money, and I think we'll be able to spin up QA much faster. So as she's talking about this, your comment might be, no, that's really interesting, Barbara. Do you think that if it's going to help us in QA, do you think Docker would help us in our development environment as well? Making a comment that expands on the disruptive change helps to convey a feeling of open-mindedness, right? I am willing to consider this. I'm actually honestly considering how this might work, and we're exploring it together. It builds that feeling of teamwork. But more than just actually building that feeling, it actually creates that open-mindedness inside you. This is part of what will help you to be more receptive to change and more honestly evaluate change. All right, make sure that you receive research, make whatever research they've done, the work that they've already done in evaluating it, make sure that you have that so to kind of give you a head start. And a great way of ending this first encounter is with a phrase like this, something like, let me do some research and get back to you. This, again, helps to create a gap between when the disruptive change is presented or suggested and when the decision is made. And that gap is really important because, again, it conveys a sense of weight to the idea. Your suggestion is important enough to have a period of time where we actually work through and determine its value. It's not something that I can make a decision on in just 2 minutes. This is bigger than that. And it also creates a space for you to do some research. When we get to the technical part, the hard skills part, you need time to get that piece done, and it creates a spot for that. Let me share a bad example. Again, this one was me. This happened about 7 years ago. A developer came and shared a presentation with me and a few other people. He had this awesome idea where we would take our large medical application with a SQL Server backend. We would split it up into microservices, each with a MongoDB backend. And in his presentation, he talked about the benefits that we would have and how easy it would be to do and how wonderful it would be to develop in this new environment. And I listened to the presentation for about a half hour, 45 minutes, and I realized that there were 4 fairly serious issues with what he was proposing. First, he was billing it as a solution to performance and scalability issues. And although microservices can help you with performance and scalability problems, it doesn't solve those problems efficiently. Second, he hadn't done any research on how the microservices would communicate with each other or how he would handle the redundant data in storage. So there was some overhead and some processes that he hadn't gone through to actually map out. Third, we actually didn't have any performance or scalability issues at the time. And so it was a solution to a problem that didn't exist. And fourth, we actually had a data-driven partitioning design that we had planned to use for our performance and scalability concerns. And on paper, it worked just as well as microservices would without the additional overhead. So after I had this thought, you know what, this isn't going to work, I stopped the meeting, I explained my concerns, and I shut it down. We all went home. There was some pretty serious consequences. There were pretty serious consequences from how I handled this meeting. First of all, it destroyed my ability to work with this developer. Whether it was real or just my perception, I felt like all of our interactions after that were stilted and awkward. And it took years for me to repair that relationship. Second, it didn't do away with microservices. The microservices topic came up again and again and again from this developer and from other developers until we finally sat down, went through it step by step, talked about the advantages, the benefits, and the concerns, and worked it out in a more detailed fashion. Third, we actually found a place for microservices in our organization. It's not our solution for performance and scalability issues, but it is going to help us to get more towards a continuous delivery environment. So it's very important to make sure you handle this validation phase, this first encounter, in an appropriate way. All right, the second step is to prioritize, to make some balance here. Now, there's a grid here on the right-hand side. It's the urgent, important grid. It's very common, very popular in project management. You've probably seen it before. It's somewhat attributed to President Eisenhower in a quote that he made years ago. But the matrix helps us to remember that we want to categorize our projects and our tasks based on whether or not they're urgent, meaning do they have a time-critical deadline that's very short-term, or if they're not urgent, it doesn't really matter when they get done, and whether or not they're important. An important item is one that has a significant impact to the long-term viability of your company. Now, up here in the top left-hand corner, we have the items that are both urgent and important. These are the fires that you need to be working on as your number one priority every day. These are things that need to get done now, or else nobody's going to have a job when they come in tomorrow or next week. So we need, when you have items that are both urgent and important, they should be your number one priority. You should be focusing on those every day. In the bottom left quadrant, we have things that are urgent, meaning they have a deadline, but they're not important. Sometimes we call this quadrant the whirlwind because we get caught up in this whirlwind and we end up spending a lot of our time here, but the stuff that we get done isn't always the most important. There's a lot of meetings, a lot of emails, a lot of reports that suck up our time in here. Hey, I need to have this by 2 o'clock for a meeting. Okay, that's great. What happens if I don't get it done by 2 o'clock? We look at it tomorrow. Aha, that one's urgent, but it may not be important. Now, most of your disruptive change falls in this top right-hand category. They don't have to be done today. They don't have to be done this week. They don't even have to be done this month. But if you don't pick the correct disruptive changes to implement, eventually, you'll find yourself falling behind in the market. So this is the quadrant where most of our disruptive change ends up. Now, why bring up the grid at all? Well, there's for two reasons. One, to help you remember, these disruptive changes need to have a higher priority than the stuff that's in the whirlwind. You need to make sure there's time carved out to focus on them. Second, if you have stuff that's in the top left-hand bracket, the urgent and important, those things need to be done before your long-term disruptive change projects. Now, here's an example of why that might be important. Let's take the Barbara and our Docker container discussion again. And we've found that Docker is up, of course, in the top right-hand corner. But we've found something else that's in the top left-hand corner. It's going to be very important for us to let Barbara know how things are working out. The conversation might go something like this. Hey, Barbara, we talked last week about Docker. And I've really thought a lot about it, and I think you're right. We'll probably save around $50,000 a year by switching and using Docker in our QA environment. And I'm really excited about that. But right now, we're really focusing on the Big Flag project. Big Flag is supposed to be done mid-next year, and when it's finished, we'll probably net the company $500,000 in new income. So right now, I think we're going to put the Docker on hold just until Big Flag gets done. And then I'd like to swing back around and help look at the security issues that you brought up to see if we can solve those and get Docker in place. Well, that's a very important conversation to have. Without that conversation with Barbara, without her understanding the priority of the Docker project, she might go above me, right? Hey, Jimmy, I talked to Chad about Docker, and I think we're going to save a lot of money, but he's just sitting on it. I think we should really do it. And now there's distraction in our organization where we're looking at Docker and Big Flag at the same time. Or she might go to the side and go over to the DevOps team. Hey, can you spin up a box for me? I want to play with Docker. I think we're going to use that. And taking resources away from where they need to be. If there's a project that's both urgent and important, it should take priority. And helping everyone understand and be on the same page where your disruptive change projects lie will help make sure that they fall in the correct order and that people aren't distracted. Let me share another story. About 3 years ago, our development team was in a bit of a bind. We had been given 37 distinct and separate mandates, things that people wanted us to do. Each one of them was listed as, this will save the product and our company. Now, these mandates had come from our executive team above us, from the sales team, product management, from our customers. There was even a few things that our development management had thrown in that they felt were important. We had a quarter, 3 months, to get them done. We looked at the list and we're like, okay, to do all 37 of these, that's like 5 years. So that's not, 3 months isn't going to happen. So what do? We held a meeting, right? That solves all the problems. We held a meeting. In this meeting, we discussed each of the items one at a time. And for each one, we asked the question, why did they ask us to do this? Why? And once we had the answer to that question, we said, why is that important? And we traced each of these items back until we found the root cause, the root reason why they wanted us to make this change. And guess what we found? Most of them had at their root a desire to improve net income. Not much of a shocker there, right? But we took that information and said, okay, knowing that net income is important, let's now step forward. What can development do to impact the net income? And some of the things that were on the list came back. These are things that we could do that would help net income. But when we looked at it from that perspective, we came up with new ideas that weren't on the list. Yeah, we actually made the list longer. Here are some things that we think are very important for development to do to support net income. And as we looked at that list, we found one item that we thought, this one thing will impact the net income the most. And it wasn't one of the 37 they originally gave us. It happened to be pushing towards a continuous deployment cycle, changing our business processes. So what we did was we went back to our executive team, the sales team, the marketing team, the customer service team, and we said, you know what? We went through this little process where we evaluated all of the mandates we've been given, and we determined that net income was important. Then we stepped forward, and we actually think that we can best meet your needs if we modify our business process to support continuous deployment. An interesting thing happened. They all agreed with us. And there was an interesting side effect in that we actually had less micromanagement after that. They realized, hey, this development team has some good management, some good processes. They make good decisions. We don't have to micromanage them. They can take care of things. There was also less politics going on around our group as well. We actually gained credibility by doing it this way. So prioritizing is an incredibly important step to have. So validate, prioritize. Third step is define success. Now, when you look at the target here in the top right-hand corner, was that archer successful? Ah, I got a yes. Those were actually the two answers I was hoping for. So thank you guys. They're not plants. Well, it depends a lot on what the archer was hoping to accomplish, right? If he's trying to hit the bullseye, he's not done a very good job. But maybe he didn't know what his goal was. So maybe he accomplished exactly what he was hoping to do. If you don't define what success means, you're not likely to achieve it. Your disruptive change should have something that says this is what's going to improve, this is what's going to be better. And the picture in the bottom left reminds us that that success needs to be measurable. You need to be able to put a number to it. If you say, oh yes, this project is supposed to, wow, don't hit the button. Set that down for a second. Oh yes, this project is supposed to improve our performance. And you run it and you say, yep, things seem to be running faster. That's a lot less specific than, oh, we were at a 3 before and now we're at a 10. Oh, I can actually understand that. Putting a number to the measurement really helps you to know what you've actually accomplished. Now, what are the common things that we use to define success? Let's go through a few of them. I mentioned one right there. Now I need to pick it up again. One of the ways we typically define success, and this is really big for us when we're working with databases, right? We're always worried about performance. That's one important measure of success. How do things perform? Now, you might be comparing it against something that's existing because you're replacing it. You're upgrading from SQL Server 2016 to 2019. You want to see how performance changed. Or maybe there's a specification that must perform at least to this level, and you're measuring against that. You also want to measure your performance as far as its variability. If you have a disruptive change project that takes your performance where it used to be sometimes fast, sometimes slow, and now it's very consistent, that is a positive benefit. I've also included scalability here, and I know that scalability and performance are different, but they're also often very closely related, right? If you have an increase in performance or an improvement in performance, I guess I should say, increase is kind of ambiguous, isn't it? If you have an improvement in performance, typically you also have a corresponding improvements in scalability. So even though they're separate things, they often end up coming up together. Another way of measuring success might be effort, the amount of time it takes to do something. Perhaps your disruptive change is a business process change that makes it so that the time it takes to get something done is shorter. It's faster to get done. That is a benefit, right? And the opportunity cost, this is another accounting term, is often a counterbalancing or a negative that you need to take into account. Opportunity cost is an accounting term that talks about what might you have accomplished instead of. So if you spend time or money working on project A, that means you're not able to do project B. So there's a cost there that B does not get done. So this is a counterbalance as well. If you have a project that increases performance, what is the opportunity cost? What other things might have gotten done that now didn't? Some of our disruptive changes have incredible amount of risk. Now, by risk here, usually high risk means high reward. So these are the very scary disruptive changes, right? If your project has a high amount of risk, that's something that you need to take into account. What is the risk if this fails, and what is the impact? Now, I have a note here in parens. If your project, your disruptive change, has a lot of risk involved, there's a tool called a failure modes and effects analysis, an FMEA, that can help you to document the risk up front and give you tools to mitigate it down the road. All right, so time, opportunity, cost, and risk. Another way of defining success, an improvement in uptime or stability. For some products, this is going to be the most important measure. One of our products is a SaaS-based practice management system for dentists. So the dentist walks into their office in the morning, they open up a web browser, and from that web browser they can schedule appointments, they can document your cavities, look at x-rays, send claims, text reminders. Everything is done through the browser window. That means that all the application servers and all the database servers are in our data center. If something happens to our data center, the office is down. They have to send their customers and their employees home. There's nothing they can do. Now, typically, we've tried to be really lean in our hardware purchases, right? We purchase what we need when we need it, and we don't buy anything extra. But for this product, there's actually a different mindset. It's actually cheaper for us to over-provision, have a database server that's consistently at 20% CPU usage, so that we don't have a 15-minute outage when somebody decides to do a table scan against the audit table, right? And this is a hard thing for our employees to understand. But uptime and stability is the #1 factor for that product, over and above cost. You might have a disruptive change that has at its target flexibility and resiliency, making you more able to quickly respond to changes in the future. One example of a project that would do this is implementing a NoSQL database, a document database like MongoDB. MongoDB is very flexible and resilient against schema changes. If you need to add a column to a table in MongoDB, you insert a row that has that column, and there it is. That's all you need to do. If you need to remove a column, no problem. You just stop inserting into it. It's very flexible and resilient against that kind of change. You don't have to go in and make a schema change in order to have what you need happen there. Another way of defining success is to measure its fitness for purpose. We just talked about MongoDB and how flexible it is, but one thing that it doesn't do really well is handle referential integrity. If your product has a requirement for referential integrity, MongoDB doesn't fit that purpose, and so it's not a good solution. Okay, my first example was a Postgres one, right? As we were building and testing Postgres in our environment, in fact, I was building a test harness that would allow us to take our production queries and rerun them against SQL Server or Postgres so we could measure their performance, their scalability, and how it handles everything. Our security architect approached me and he said, you know what, I've been looking at Postgres and its security, and I can't find a way to secure the data appropriately since we have HIPAA data in there. He says, I don't think it's going to work because it just doesn't have the security that we need. Postgres didn't have fitness for purpose, so it wasn't a solution for our environment. Now I have to ask, does anybody in here use Postgres right now? Or used it in the past? Okay. Do you understand Postgres security model fairly well?
In passing, I mean, yeah, as far as we needed to for what we're using it.
Okay. So the reason I bring this up is this isn't the end of the story. I've got one more piece. So my worry was that somebody would come in and say, Postgres can secure HIPAA data. And I have the answer for that in about 3 slides. So let's hold on, and I'll finish the Postgres story, and I'll give you the conclusion in the next episode. After the commercials, we'll be right back. Okay, fitness for purpose. All right, cost. This was the one that we almost always use, right? There's almost always a cost involved, either a cost benefit or an expense due to our disruptive change. Now, just because there's a cost benefit, it's going to save us money, it doesn't necessarily mean that it's a project that we should do. Nor if there's a cost detriment, meaning that it's going to cost us more money, that doesn't necessarily mean that we should can it. These might be counterbalanced by other factors, right? Maybe we're having an increase in performance and an increase in cost, but the increase in performance is greater than the increase in cost. In fact, many of your projects will have one or more of these, will have more than one of these factors embedded in it in some way. You're probably not going to find one that has all of them, but you'll probably have 2 or 3 of them that you're going to measure. How do you balance those all together? How do you determine whether or not the increase in performance and stability is counterbalanced by the decrease in flexibility? How do you compare those together? Ideally, you compare everything on the basis of cost. Can you turn an increase in performance into a dollar amount? Well, yeah, you can. If I can make a query run more efficiently or run faster, I need less hardware. So I can put a dollar amount on that. If I have something that's going to shorten the time it takes for us to do a release, can I put a dollar amount on that? Yeah, I can. I can turn all of these factors into a dollar value. And there is some incredible value to doing that. For one, it takes care of the problem of trying to balance each of these factors against each other. Some of them will be positive, some will be negative. How do I counterbalance those? Second, it really helps you when you're comparing projects. Remember back at the beginning where we said Big Flag was a $500,000 project and Docker was a $50,000 project? Bringing everything down to a cost factor really helps to understand which projects should be done first and which projects should be done second. And what you'll find when you get into doing this is that you'll find a project it's a $1,000 project. And you go, yeah, we've already spent more than that trying to figure it out. I think we're done. And those are the ones that are really kind of fun. You're like, wow, I really thought this was going to be a big deal. It turns out to be an incredibly small deal. Let's move on. Okay, so we've talked about validate and prioritize and define success. Okay, our third step is to do a spike. Now, this is where we're going to actually determine whether or not the benefit that we expect is actually going to be realized. Ideally, we're going to do this in an apples-to-apples way. And let's use as an example, I got this great book by Bob Ward this week that talks about 2019. Chapter 2 is all about the performance benefits. I think if we upgrade from 2016 to 2019, our performance is going to improve. If I want to do an apples-to-apples comparison, I'll take our current queries that are running on 2016 and replay them against a production level host under 2019, and I'll see how they run. That is an apples-to-apples comparison because it'll tell me exactly what I'm going to see when I upgrade to SQL Server 2019. That's an awesome way to do a comparison, an awesome way to make sure that you will see the benefits that you expect. The problem is, this is often really time-consuming. It takes a long time to do, to set up, and it's hard, and it's sometimes very expensive, right? I've got to have a copy of production. I've got to go gather all of the queries. I've got to figure out how to replay them and get them to run again. So it's the best solution, but sometimes we don't have the ability to do an apples-to-apples comparison. When we don't, what do? Well, let's do an apple-to-pear comparison, right? They're both fruit. They both grow on trees. They have similar nutritional characteristics. They're different colors, different shapes, different taste, very different textures. An apples-to-pears comparison might be, well, I don't have production hardware, and nobody's going to give it to me, so I'm going to do the comparison on my own box. Does that mean that it's going to be the results that I get on my own box, are they going to be exactly the same as what we'd see in production? No. Are they probably kind of close? Probably. Let's hope, right? Or maybe I'm not going to do all of the queries. I'm going to test the most important ones. The biggest ones are the ones that run most often. That's not a perfect test. I'm making some assumptions that what happens on my box with this smaller set is what's really going to happen when we get out into production. So it's not a perfect match, but given what I have available, it's the best test that I can do. Now, it might be that you can't do an apple-to-pear comparison either, right? You still don't have the money, you don't have the time, the decision has to be made quickly. Well, then we can do an appraisal. Now, when you try to sell your home, they do an appraisal, right? What happens? There's a guy that comes in, he walks through your house. Hopefully he doesn't see where you hid the dirty laundry, but he checks the number of rooms, the size of the rooms, the property, the quality of the materials, and then he goes out into the neighborhood and looks at houses that have been sold recently, and he says, your house is a lot like this one and that one and this one. I know what those 3 houses sold for, so I'm going to guess that yours is going to sell for about the same. That's what an appraiser does, right? You can do that with your disruptive change. What does that look like? Well, here are some other companies that have made the same disruptive change, and here's what happened there. I'm going to guess that that's the same thing that's going to happen for us. Now, where's the risk there, right? Well, let's see. Are our companies really the same? Do we have the same employees, the same skill level? Did they actually do their tests the right way, and are they reporting all of the information? There's a lot more risk involved in doing an appraisal, but if that's what you have time to do, and you can't do the apple-to-apple or apple-to-pear, it's certainly better than taking a quarter out and flipping it, right? So it is something. Here's where we finish the Postgres story. Our company wasn't able to secure Postgres such that we could put HIPAA medical data in there. Your company might be able to. I'm sure there's some company somewhere in the world that is using Postgres to store medical information, and they've got it secured appropriately. We didn't know how to do that. We had to do our evaluation based on our skill set and our abilities, not yours, not yours, and not yours, and not Jonathan's either. We couldn't do it on any of those skill sets. We had to do it based on what we could do. What does that mean? That means that the disruptive changes that we implement or don't implement might be different than the disruptive changes that you implement. And we're both right. You have to do the evaluation based on your company and your situation, where you are now. Okay. After we do the spike, it's time to do some analysis. This is where it's going to get fun. So, 2016 and 2019, let's see. I ran everything under 2016. My critical job took 100 seconds. And when I ran under 2019, it took 90 seconds. That's a definite improvement. We're good to go. Ta-da! Except what happens if I ran it again under 2019, and this time it took 110 seconds, or maybe 85 seconds. One run isn't enough to really tell, is it? No, it's not. Okay, I need to do multiple runs, right? And that is the answer. But even with multiple runs, there's a little bit of diciness built into that. And I think that a physical example will help us to understand that a little better. Okay, I have here a bag. And inside this bag are some tiles. And I'm making it loud for the people who are at home listening. All right. Now, I want you to imagine with me that inside this bag there's 1,000,000 tiles. And you know there's not 1,000,000 in there. I didn't have enough money to buy 1,000,000 tiles. I didn't have a bag big enough to hold them. But it's going to be important in just a minute that we all agree that there's 1,000,000 tiles in here. And on each of these tiles, I have written a number. So this is our SQL Server 2016 job that we're trying to measure its performance. And each of these numbers represents how long in seconds it took to run that job. So if I pull a tile out of the bag here, and I look on it, this is simulated running the job. It took 44 seconds. Okay, so I ran the job. It took 44 seconds. And I'm going to run the job again, and this time it took 30 seconds. And I'm going to run the job again. This time it took 40 seconds. And let's run it a couple more times. And I got a 47. And I got a 28. One more. Ooh, a second 44. Okay. Now, I'm going to run this job a whole bunch more times until I have 75 runs. And now I have some really great information about my SQL Server 2016 job, right? I do. I can take an average, and I have an idea of how long it's going to take how long it takes that job to run. But I want a little bit more than that. I actually want to see it graphically. So let's build a chart. Let's build a histogram. To build a histogram, the first thing that we're going to do is put a number line across the bottom. And then we're going to make a little mark for each of our numbers. The first one that I pulled out was a 44. So I'm going to put a little mark about right there, 44. Okay. My second one, where's my second one? Second one was a 28. So it goes about right there, 28. And the third one, I think, was the 47. Oops, I went backwards. 28, 47. And then the 40. Our next one was the 30. OK, then I got another 44. What should I do with that one? I've already got a 44 up there. I'll just stack it on top. OK? Now I'm going to do all the rest of them. And as it starts to fill in, not only do you get to see a typical run, right? You can kind of see where everything centers. But you also get to see a little bit more about the pattern that my data creates. Now you can see that on average, this job under SQL Server 2016 seems to run about 35 seconds, right? That's where the middle is. And you can see that sometimes it runs as long as 50 seconds. Sometimes it's as fast as about 22. But in general, it kind of centers around 35. Does this pattern look familiar to anyone? It's the bell curve, the normal curve. I believe it's also called the Gaussian curve, right? This curve actually is so popular that it has a name, and that's because it shows up so frequently when we gather data. Now, what I want to ask you is if I reach down in here, and here's where it's important that we have a million tiles in here. If I reach down in here and I pull out another 75, will I get exactly this same picture again? I might get something really similar, right? But probably not exactly like this. It might be shifted to the left just a little bit or shifted to the right just a little bit, right? But it's going to look pretty much exactly the same. Now, if it's shifted a little bit to the left, does that mean, woohoo, it's running faster now? No, it just means I got a different 75 out, right? And if it shifts a little bit to the right, does that mean, oh no, now it's running really slow? No, I just grabbed a different 75 out of the bag. So small shifts in this graph don't mean anything. That's just random variation, right? OK, now, what we're going to do now is we're going to redo our process, but this time with SQL Server 2019. OK, so we're going to start over. Now, if SQL Server 2019 doesn't improve performance, then I can just draw more numbers out of this bag, right? Because nothing's changed. This is the performance for 2016 or 2019. It doesn't matter. If 2019 doesn't improve performance, I draw out of the red bag. If 2019 does improve performance, I can't use these numbers, right? I need a different bag. So now we need to figure out, does SQL Server 2019 actually improve performance? What I'm going to do is I'm going to draw numbers out of one of these bags, but I'm going to do it under the table so you can't see which bag I'm using. All right? And your job is going to be able to tell whether or not SQL Server 2019 improved performance. OK, so here's my first tile. That's a 30. And my second one is a 22, and a 37, and a 25. And I'm going to keep pulling numbers out until, again, I have 75. Now, if I create a histogram, and it looks something like this. OK, what do you think? 2019 improved performance? Well, it certainly shifted, right? We used to average about 35, and now we're averaging 32, 33 or so. So it certainly looks better. But is it better because 2019 is better, or just because I pulled a different 75 numbers out of the same bag? You think the last one? Would it be easier to tell if I overlaid the two graphs so you could see them at the same time? It would be. And I'm going to do that, but not right now. First thing what I want to do is I want to show you 3 different ways the graphs might look when they're overlaid, and then we'll look and see what they really look like. Okay? So here's one way. If the graphs are overlaid and they look like this, what would you conclude? You say, yes, did it improve performance? Okay. Well, let's see here. If I drew, what if the items in the red bag, the numbers in the red bag, actually had a distribution that looked like this? Is it possible that the first time that I pulled out numbers, I got all of these, and the second time that I pulled out numbers, I got all of those?
Possible, but not likely.
Okay, that's exactly the right answer right there. It is most certainly possible, yes. I could have luckily gotten all of the big numbers the first time and all of the small numbers the second time. It's definitely possible. However, it is incredibly, highly unlikely. It's like randomly picking people from the United States, measuring their height and getting all NBA basketball players. Sure, that could happen, but it's probably not going to. Okay, so if the graphs look like this, we're going to determine, yes, SQL Server 2019 was indeed faster. What if the graphs look like this? If the graphs look like this, is it possible that we pulled both the red numbers and the green numbers out of the same bag? Yeah, it's certainly possible. Does it mean that we did? No, it doesn't necessarily mean that we did pull them out of the same bag. But if I did, if the green ones are the numbers in the blue bag, you'd probably conclude that, yeah, okay, so you pulled numbers out of a different bag, but they're all pretty much the same anyway. Yeah, it made a performance difference, but not much. All right, what if, oops, I went the wrong direction. There we go. What if we put the graphs together and look like this? Somewhere in between those two is an area that gets really hard to eyeball. Really hard to eyeball. Luckily, you don't have to eyeball it. There's actually a mathematical equation that you can use to determine whether or not those two humps are close enough or far enough apart. And that mathematical equation is called a t-test. When you compute the t-test, it gives the output of the t-test is called a p-value. The p-value is the probability that these two sets of data were pulled from the same place. Or in other words, if we were pulling two sets of data from the same place, what are the chances that they would end up looking this far apart? Now you can see over there on the right-hand side, we have the two humps we looked at first. And the probability that those two came from the same place, excuse me, I've got to phrase this right. My brother has a doctorate in statistics, and he'll listen to this someday, and he'll be on me if I don't phrase this just perfectly. So let me try that again. If we pulled two data sets from the same place, two sets of data from the same spot, the probability that they would look like this is 1 in 10,000. Did I get it right? You're nodding your head. Okay, good. On the left-hand side, if we pulled two sets of data from the same place, there's a very high probability that they could look like this. Somewhere in the middle is the dividing line. The industry standard dividing line is 0.05. If you have a p-value that's less than 0.05, your conclusion is yes, the probability is so low that we're going to decide that these two data sets came from different places, meaning the performance for 2016 is different than the performance for 2019. Anything greater than 0.05, then we decide, well, yeah, the performance might be different, but it's small enough that we really can't tell, so we're just going to say that it's the same. Now, how do you do a t-test? There's the equation down there in the bottom right-hand corner. I computed this by hand when I was in college. It's a lot of fun. The problem is you make one small mathematical error and the whole thing's wrong. You got to start over. So let's not do it by hand. Let's use Excel. Excel has a t-test equation. It takes the 4 parameters, your two data sets, a tail type and a test type. Now, the tail type most often is going to be 2, and the test type, again, is most often going to be 2. So for most of your cases, you're going to use 2 for both of those parameters. There are other programs you can use that will also do a t-test, and they work really, really well. But since almost everybody has access to Excel, let's do it there. It just so happens that I have our data sets in Excel. The before column is all of our test data from 2016, and the after column is all of the test data from 2019. So let's go ahead and do it. Equals t.test. And we need to give it our first array, which is our 2016 data. And we also need to give it our second array, which is our 2019 data. And our two-tailed distribution, the 2 tells it it's a two-tailed distribution, and then we're assuming that they have equal variance. And again, in most cases, those are the appropriate parameters for you to use. And it gives us a result. All right. Oh, yeah. Got my zoom off. There we go. So this is our p-value. Is this bigger or smaller than 0.05? Smaller. Okay, so what do we conclude then? That's exactly right. We conclude that SQL Server 2019 was indeed faster than SQL Server 2016. Awesome blossom. Okay. All right. That t-test gives us what's called statistical significance. Since it came in at less than 0.05, we can conclude that we did make a change. There's one other test that you need to do, and that's a test for practical significance. Here, we've determined that, yes, our performance did improve. It went from 35 seconds to 33 seconds. Woohoo! Now, is that enough of a change that anybody really cares? Maybe. If, when you define success, you were able to measure the impact of an improvement based on dollars, you could actually say an improvement of 2 seconds means this much in cash. Well, that's really cool, right? What's a 2-second performance increase look like in cash? If this is a query that runs 1,000 times a second, oh yeah, this is a big deal. If it's a query that runs once a month, well, that was a great exercise. Let's move on to something that's next, right? Okay, so you need to do your statistical and your practical significance. Okay. All right. Once you're done, the next thing to do is to deliver the results. Now, the first 3 steps here are very important regardless of whether or not you decide you are going to make the change or are not going to make the change. Make sure you document this process really well and that you share that information. This is what builds cohesivity and unity, right? Everyone's on the same page. Here's how we determined the priority of the project. Here's how we determined what success was. Here's how we measured the before and after. All of these items help to make sure that everyone's on the same page and understands the relative importance of what's been accomplished. These last 2 are really important if you decide that this is a disruptive change that you're not going to implement. Find a place where it will work. You found a place now that it won't. Is there another place where it will work? This helps soften the blow and helps direct people's enthusiasm into an appropriate place. Also make sure this is an opportunity to receive feedback again. There might be something that you've missed, something you didn't consider, particularly if you didn't have everyone involved in the process from start to finish. There's an opportunity there to make some adjustments that you may need to do. Now, disruptive change can be inherently scary, but it doesn't have to be. Disruptive change is an opportunity. It's an open door. It's something that can help you increase your influence. It can help you promote your career. And oh yes, it can help your company too. We should be excited about disruptive change. We've talked about 5 different things that you can do to correctly analyze a disruptive change to determine whether or not it's going to be successful. And we also talked about how to deliver the results. Now, with this information in hand, you can correctly analyze and implement disruptive changes in your environment and increase your influence and your ability to lead both people and processes. All right, make sure that you fill out session evaluations. There's money involved in this, right? 2 sets, 1 gift card that'll go out tomorrow, and another a free ticket to pass next year that they'll hand out. I think is it next week, the week after? So make sure you fill out your session evaluations. And I'm here. I'll take some questions because we still have a few minutes. I rocketed right through that. We've still got time for questions, and I'll stay here until the next presenter gets here and kicks me off. Yes.
I mean, obviously this could get time-consuming. If you've got a team that's like giving you new ideas every week or something, how do you sort of like pre-screen, so to speak?
Okay, very good, very good. That is a great question. So first, the very first one is going to be very slow, because what you're going to end up trying to do is push this process and this methodology down. As you go through it once, ideally, you go through it all together and say, okay, let's take a look at this. How are we going to prioritize this? How are we going to measure success? Let's actually do an evaluation. After you've done that 2 or 3 times, what you'll find is they'll bring it to you having that work already done. So ideally, this is a training opportunity. That just means that I was so completely and perfectly clear.
Do it the other way around. When your management doesn't do any of this, and you want that change.
Okay, great, great. So the question is, how do you do this when your management isn't doing it for you, but you need to implement something like this? Okay, I've seen this happen to people before as well. And here's what ends up happening. They end up doing it themselves, right? You would end up doing this and saying, all right, here's the process that I went through for this disruptive change, and now I've gone all the way through, and here's the data that I have that shows that it's going to be successful. Here's the data that I have that it's the most important thing for us to work on now. And as you pass that information up, you make the job really easy for the person that's above you, right? Because you have brought a solution that's completely vetted, and you can actually show all the other things that were vetted out. This one was vetted in, that one was vetted out. Now, what that will do is that'll make their job really easy. It'll increase your influence in their perspective. And what you'll find is you end up doing, I dare say it, you end up doing part of their job, right? And that becomes visible very quick. And what I have seen happen to people is that they end up getting promoted up to the level that they have the influence that they're willing to handle. It's not always a fast track, but it is. It appears to be a fairly good track. Does that make sense? Okay. Yes.
This is kind of really simple.
Okay. So let's take just one. Let's just take one of those. Let's take the hardest one, and see if I can work through it. I'm not sure that I can, but I'm gonna try. Attracting top talent. So the question was, how do we take some of these other more complex situations and apply this type of methodology to it? And attracting top talent, how do we numerically define success for that? Okay, so getting practical hard numbers is going to be challenging, but you can get numbers that are reasonable and are defendable. So attracting top talent does have a financial impact on its success, right? If you're able to attract good talent, they're able to get more work done than moderate talent. If you're able to attract top talent, you're able to then again attract better talent as well, right? It's not better talent, but you're able to attract more talent. It's easier to attract talent when you already have some, right? Now, what is the financial impact of that? What is the financial impact of someone who can in a 40-hour week can accomplish 60 or 70 hours of work? Right? There's one way of measuring it. What is the impact of someone who in a 40-hour week writes code that only has a couple bugs in it versus someone who in a 40-hour week writes code that has more than that in it? So as you go through and you weigh what does top talent mean and what is their impact, is you measure all those things out. Fewer bugs, more throughput, higher stability. Those are things that you would look at and say, okay, what is my best estimate for the financial impact of that? Now, the key piece when you have items that are more difficult to measure, right? Measuring performance is really easy because SQL Server will actually spit out a number with several decimal places. This is how fast it ran. When you're looking at how many bugs is someone with top talent versus someone with moderate talent going to crank out, that's much harder to do. So how do you get a number that's defensible? And the way you do that is either doing market research, which I don't know if there is any for that, or working as a group to come to a consensus. So at that point you say, all right, let's have 5 of us sit down. We want to talk about somebody that works at this level and someone that works at this level. What is the difference in the number of bugs that they create? And you have a good discussion and come to an agreement. Well, we think that type of a person would create half as many bugs. All right, what is the financial cost to having that many bugs? Well, there's time according to rework. There's loss of customers who attrit away from our product. and there's loss of the, what do you call it, how the industry feels about your company? Your NPS score type stuff. What? Sentiment. There's bad sentiment. Bad sentiment is really hard to measure financially, right? All right, well, let's talk to our marketing team. Let's say, okay, hey, if our product has a reputation for always being buggy, how much is that going to impact our sales? Oh, I don't know. Well, give me a guess. Here, this much. Okay, and you get 5 marketing people to discuss it and come to a number. At the end of the day, what you have is a number that's not perfect, it's not accurate, but it's a really decent shot. Yes, but the neat thing is that it's actually possible, right? Even if the numbers that you're getting are based on consensus, you've turned it into a financial value that now allows you to compare that against something else that you're going to do, right? So how much time do we spend working on improving our ability to recruit top talent versus how much time do we spend implementing, I think it'd be technology X. And if technology X is going to, have less of an impact than doing top talent, then we need to legitimately spend more time working on top talent and less time worrying about this new technology. So it helps us to balance those in some way. Or without that, I really feel this is important. And those kind of decisions don't have any basis except for, gut feel.
Would some of that also go into like your risks? As far like when you were talking about like the upgrades, like whether or not you're going to end of life if the product's going end of life, I mean, that's risk cost.
Oh, right. Okay, so the comment is some of this goes into risks as well. Like if you have a piece of hardware that's end of life, you're not going to be able to get support. Yeah, then fixing that problem, you're going to look at, if support goes out, our uptime, what's the chance of having an outage? What's the cost of that outage? What's the chance of needing increased maintenance or increased monitoring? We've got to have somebody on call 24/7, and what does that do to burnout? And what does that do to our employee retention? And so there's a lot of things that you can factor in there but the risk piece there can then again be couched in a monetary value that you can use to compare side to side. Let me think. There's an experience that we had. We had an outage at one point that was fairly serious. And at the time, we thought that the financial impact because of that outage was incredibly immense. As we actually went back about a year later and did the analysis on it, we found that the impact was much smaller than we expected. Everybody was really not excited, but really up in arms about the outage, and we actually found out later that there really wasn't. All the impact that they thought they had never actually surfaced. But we wouldn't have known that if we hadn't gone back and tried to measure what was the impact based on attrition, what was the impact based on all the financial outlay that had to go into that outage. So we were actually very surprised about how that one came out. Great questions. I love that question because we get to talk about the soft piece, the pieces that are harder to get numeric values for. All right, thank you guys. I appreciate your attendance today. One more session, and then you get to go home.